Hello, everyone. We are Team Sediment, and this will be our project on design of improved anti-fog sprays for performance and durability. So over the pandemic, a lot of us wearing glasses have had a pretty common issue pop up. When wearing masks, our glasses tend to fog up, and this can reduce visibility quite a bit. This can generally be a problem in colder or more humid climates as well. And we've seen in professions like bus drivers or healthcare workers or lab workers that they're often affected by this, and it can even be dangerous in some circumstances. So with our project, we wanted to improve commercial anti-fog products and as a result, improve workplace safety. So some of our goals for this project were to design and fabricate a photometer for fogging measurements. We also wanted to improve on the existing commercial formulas and focus on durability and transparency. With our durability, we wanted to make sure that each of our samples would withstand 10 cleaning cycles. The cleaning cycle would be like someone cleaning their glasses with the microfiber cloth. We also wanted to make sure we maintain transparency with the transmittance above 98%, which would be acceptable for wearing eyeglasses.
So much of our project was designing a custom photometer to test multiple anti-fog solutions. During our research phase, we struggled to compare solutions between studies, as most of them simply demonstrated anti-fog effectiveness with a photo of fogged glass over paper and text. Without a consistent and quantitative comparison, it would be difficult to design a better solution on our own. As such, we designed our own photometer in SolidWorks, and we 3D printed it out of ASA due to ASA's high glass transition temperature and minimal water absorbance. Samples are loaded in at the top near an opening, which controls the release of fog via a sliding door. The vapor chamber was heated and maintained at a temperature of 50 degrees Celsius. Transmittant values were collected by the Arduino using a photodiode, and transmittance, vapor temperature, and humidity are recorded and stored on a micro SD card to be analyzed in MATLAB. We went through several design iterations of the photometer, both in terms of physical design and circuit design, and the image on the right represents our fifth and final iteration of it. Overall, we tested 10 commercial products of various brands, price ranges, and application types. We used various sprays, wet wipes, and a dry wipe. We made 6 modifications to the products to test in the photometer. Polycarbonate and CR39 substrates were used as they are the most common lens types on the markets today. We found out from our photometry results that the reduction in transmittance by the fog was rather low. Most samples were above 96% transmittance, with the control polycarbonate being the lowest at 94%. That means that the vision obscuring aspect of the lens fogging is more from scattering light than in the transmittance reduction directly. A more effective test for distinguishing products was dissipation time of the fog. Samples in the photometer defogged more slowly despite the vents, and this made a bigger gap in product performance. Some of the products took up to half an hour to defog, while others took mere seconds. We found that wipe J was the best performing product overall, and C and A were the best sprays. As extracting the liquid from the J wipe would be difficult, we chose to modify sprays A and C instead.
We also implemented consumer trials into our design process, where we selected 12 individuals to each test 3 different anti-fog commercial products. The consumers were then asked to write their experience on the ease of use, effectiveness, and anti-fog ability, and their overall personal preference among several other preliminary questions. Below is a photo of the samples that were distributed to our consumers, with instructions on how to use each specific commercial product. The consumer trials results showed that overall, anti-fog wipes and sprays were evenly matched in terms of consumer preference. Consumers all preferred an occasional application of their anti-fog product rather than a frequent application. Products C, H, and F were the most favored commercial anti-fog products amongst consumers. On the right shows a graph of the ranked commercial products. The graph shows scores each participant gave on a scale of 10.
Initially, we had planned to create a custom anti-fogging solution with hand-picked anti-fogging agents, and while we did make a prototype of this, our testing showed that this wasn't necessarily the direction to go. Photometer testing had shown that the existing commercial products already had good anti-fogging properties with high transmittance values and low defog times. However, all of the products had low durability, and consumer trials had already shown that everyone preferred products that they had to apply less frequently. Due to these conclusions, we decided to pivot from creating our own solution to modifying existing products to improve durability. We researched various different binders and found a very promising one from the cosmetics industry, dimethicone. As previously mentioned, we decided to modify product A and product C as they performed the best in the photometer experiments. We added various concentrations of dimethicone to them and put them through degradation testing. We designed our degradation testing to measure the changes in transmittance and defog times with a number of wear cycles. The wear cycles would mimic the degradation that the coatings would experience when cleaned with a cloth or someone's shirt. We would run the sample in the photometer, take it out, wipe it with a microfiber cloth, run it in the photometer again, and repeat for 10 cycles. And across the board, our results showed that our modified samples maintained equal or higher transmittance values and lower defog times with wear. Additionally, higher concentrations of dimethicone correlated with higher durability.
Okay, and to sum everything up, these are some of our accomplishments over the course of our project. We have designed and fabricated a custom 3D printed photometer from scratch. We've also performed 12 consumer trials to gain insight on our 10 commercial products, and we gained valuable quantitative and qualitative data. And we additionally made 6 modifications on the best existing products that we found from the photometry and consumer trials to have a better durability as a result. Now we are planning to contact some of the companies that have made the anti-fog products. And we want to sell them our binder agent process as an improvement to durability. All right, thank you everyone for listening to our presentation, and we look forward to your feedback.